Let's discuss part 2 of types of relations. This lecture is in continuation to the previous lecture. Therefore, I would recommend you to watch that lecture first before moving on to this lecture. Okay? Here we will discuss the fifth type, that is transitive relation. A relation R on a set A is called transitive if for all A, for all B, for all C, A, B belong to R and B, C belong to R implies A, C belong to R. As simple as that. Here if A, B belong to R and B, C belong to R, then this means A, C must belong to R. Then only we can say relation R is transitive. Let's see one example. Let's say we have set A which consists of these elements and R8 is defined on set A. Here in this R8 we have these ordered pairs 2, 1, 3, 1, 3, 2, 4, 4. Now this relation is transitive because 3, 2, 2, 1 and 3, 1 are there in R8. You can see that 3, 2 is there, 2, 1 is there. Therefore 3, 1 must also be there in R8. And you can see that 3, 1 is there in R8. Therefore this relation is transitive. As simple as that, right? Let's consider one more relation, R9. Here in this relation, we have two ordered pairs, 2, 1, 1, 3. This relation is not transitive, let me tell you, because 2, 1 is there in R9, 1, 3 is there in R9, but 2, 3 is not there in R9, right? Therefore, this relation is not transitive. This is all about transitive relation. Now, we will discuss the sixth type or last type of relation, that is asymmetric relation. A relation R on a set A is called asymmetric if for all A, for all B, A, B belong to R implies B, A does not belong to R. If AB is there in R, then BA must not be there in R. Then only we can say R is asymmetric. This is more stricter version of symmetric relation, right? Let's discuss one example. Let's say we have set A. Again, I'm considering the same set. And let's say we have R10 relation which is defined on set A. And here in this R10 relation, we have these ordered pairs 1, 1, 1, 2, 1, 3. You can see that this relation is not asymmetric because 1, 1 is there in R10, right? Even ordered pairs of the form A, A are not allowed in the relation. Okay, so it is clear that R10 is not asymmetric. Let me tell you that in case of antisymmetric relations, we are allowed to include ordered pairs of the form A, but ordered pairs of the form A must not be there in the relation. Okay, let's consider one more relation, R11. Here in this relation, we have these ordered pairs 1, 2, 1, 3, 2, 3. Now this relation is an asymmetric relation because for 1, 2, there is no 2, 1. There is no 3, 1 for 1, 3. There is no 3, 2 for 2, 3. Therefore, this relation is an asymmetric relation. Okay. Now, let me just put the summary of all the relations together in one place. Here is the complete summary of relations with their properties. Reflexive relation means for all A, must belong to R. Irreflexive means for all A, must not belong to R. For symmetric relation, we have this property for all A, for all B, A, B belong to R implies B, A must belong to R. Antisymmetric relation says for all A, for all B, A, B belong to R and B, A belong to R implies A is equal to B, right? Asymmetric relation says for all A, for all B, A, B belong to R implies B, A does not belong to R. And in case of transitive relations, we have this property that is for all A, for all B, for all C, A, B belong to R and B, C belong to R implies A, C belong to R. As simple as that, right? So these are all the different types of relations we have. Total 6 types: reflexive, irreflexive, symmetric, antisymmetric, asymmetric, and transitive. We must always remember what these relations are. Okay friends, this is it for now. Thank you for watching this presentation.